Hello, Randy here, K7AGE. Short video here to talk about your sound card interfacing to your radio. You basically have to take care of three items. You have to get audio from the computer to the radio to transmit, audio from the radio to the computer to receive, and then a way to key up the radio to put it into transmit. You can do this with a simple cable. There's one that I've made for my FT817, FT857. It has two connectors here for the audio to go into the sound card for in and out, and then a card here that plugs, or a connector here that plugs into the serial connector that we pick up one of the control lines, and inside here's a transistor circuit that's used to key the radio. And then on the other end I have a plug that plugs into the back of the radio, and all the ins and outs and keying circuits are available on there. In a few minutes I'll show you some instructions about some plans for the cables. Another way to go is with an interface. There's many to choose from and all sorts of price ranges. This is a little rig blaster. It's an older one. It's been around for a long time. They still sell these types of devices. And what this does is handles the signal levels and maybe a transformer to prevent ground loops between the radio. If you have a ground loop, you may end up with hum or noise, especially when you transmit. So these types of devices have a transformer in there. It has a connector on the back which connects to the serial port of your computer, mainly to pick off the DTR or RTS line to key the transmitter, and it has a couple jacks for audio in and out over your sound card, and then it has another jack here that a cable plugs into with like an Ethernet connector, and then it plugs into the microphone jack on your radio, so that when the computer keys up on the radio, the sound goes through the box here and goes into the microphone input. Also in the front is a microphone jack that you can plug in your local microphone so you can still operate voice normally. This type of thing makes it easy to switch back and forth. You don't have to unplug cables and such. Another interface that's fairly new is this Tigertronics. It's a USB signal link. What's kind of unique about this, and we're seeing this now in many of the newer interfaces, that this has basically a sound card built inside. The complete sound card electronics is built in the box here. So now the interface to the computer is just a USB line to the USB port. It's a lot more modern and makes it easier with computers that don't have serial ports. One of the things I like about this is that it has knobs in the front here, so you can set your levels. Sometimes you may find that you're off a little bit for transmit. It's just easier to reach up here and change the level than opening up the sliders in the Windows control things. This can take a little more fiddling around to get things interfaced properly, because now you got to deal with two sound cards in your computer. You have your normal one for your Windows sound, and then this one needs to be selected in your sound programs in order to make the correct sounds for transmitting and to receive through here. Something you have to be careful about with all the interfaces is watching out for your Windows beeps and burps and dings and dongs and you got mail. You don't want that type of stuff going out over the air. So either turn those applications off, which is probably the easiest thing, or go into the Windows sound setup and sound manager, I believe, and you can control or turn those sounds on and off. Some of the instructions and plans for your own cable, if you look into almost any of your software that you may be using, Digipan, look in the help files, and typically there's a set of instructions and some information about building up various types of interfaces and such. So in the Digipan here, it has a little schematic for a attenuator, which you may need. Let's talk about line level and microphone level for a minute. Most sound cards now have maybe line in and output, or a microphone in, or sometimes only a microphone in and a line output. These are different levels of signals. The microphone is about 1/100th of the level of a line level signal. So if you're coming out of your computer with a line level output going into your microphone input, you're going to have way too much signal. So you need a attenuator, which is real simple. A couple resistors is all you need to put in line with your cable, and it'll drop that. A commercial interface box has that built in for you. Also, many computers now, especially laptops, do not have line level inputs. So when you come out of your radio, you'll typically be coming out hopefully a line output which is fixed, so it's not variable with the volume control, or maybe a speaker output. But that's way too much signal to go into the microphone input. So again, you may need to have an attenuator to drop the signal down to mic level. And again, a commercial interface box like the Rig Blaster or an MFJ or something will take care of that for you. Another good page of information is Ernie Mills, WM2U, William Mike 2 Uncle, soundcard interfacing page. Just do a Google search with his call and soundcard interfacing, you'll find this. He has a lot of information here, little schematics of the attenuators, schematics using transformers, which I'm not sure you can still buy those at Radio Shack anymore or not. And he has some Buxcom part numbers. Buxcom also sells little interfaces as well. He also has tabs here in the middle, which are for each type of radio, and the connectors that are available and the pinouts that you may need to deal with for that. Spend some time looking over that site. So I think that about does it. You should be able to get going on an interface, look over some of those instructions and sites, looking at the schematics. You can decide to build your own, or maybe take a look in the magazines and websites. Again, Rig Blaster, MFJ, Buxcom, Tigertronics, there's all sorts of people building interfaces. You can have simple cables, you can have rather, boxes that are fairly straightforward. Something of this variety is about $50. The signal length USB box with the USB sound is about $100. I use a Rig Blaster Pro on my TS2000. That's kind of high end. I wouldn't recommend starting with that. You can have a lot of fun with something fairly simple, and maybe after you try this a little bit, you won't like it, so no sense spending a whole lot of money and time to get going. The cable here is probably maybe a 2-hour project, and you got some fine working inside here. I actually built the attenuator right here in the middle. See, I have the 3 lines coming in, and this is just all taped to a cord. You can buy these from MFJ. They have various the mini DIN cables for the radios, which have no connectors on the other ends. A lot cheaper than buying them through Yaesu or Kenwood or whatever. So anyway, I have my resistors inside here for my attenuator, and it's just all wrapped up in tape. So it's 3 connectors on one end and the other way. Works fine for my 817 and 857. So that should get you going. Probably should just talk about transmit level a little bit in case you get on before I come along with my next video. One of the things you want to be real careful of is that you don't overdrive your transmitter. You overdrive your transmitter, you're going to make a lot of distortions and splatter and have signal all over the band where you don't want to be, and that's not the way you want to operate. The way to do that is you adjust your audio level, so you just start to see a little ALC, and you can also watch your power output if you don't have an ALC indicator. Just bring your level up and you watch your power go up, and then just back it off so your power just starts to drop down a little bit. That ensures you're running in the linear part of your transmitter. If you overdrive it, as you turn your level up, the transmitter power would just go up, and it will stop at a certain power level even as you increase the audio. As you increase the audio, you're just causing distortion. So when in doubt, back it down just until the power comes off the needle, comes off the maximum amount. play around and get some signal reports from other people. You'll see, if you watch PSK on the bands a while, you'll see what clean signals look like and what wide signals look like. Instead of just having the two little bars for a clean signal, you'll see the two main ones and lots of other little bars off to the side. This is not what you want. 73s. Have fun. I'll talk to you later. Bye-bye.